All right, in this lesson we're going to talk about an overview of the types of chemical reactions, and we are going to also talk about the first two, which are composition and decomposition. So before we start the overview, let's define our codes up here. A and B we'll use to represent metals, and X and Y we're going to use to represent nonmetals. So our first type is a synthesis reaction, and what we're doing in a synthesis or composition reaction, occasionally you'll see it called a combination reaction, is we're taking two simpler substances and we're creating one more complicated. So in this case we would do A plus X yields AX. So that would be a metal and a nonmetal. That's one type. We are going to recognize if something's going to be a composition or a synthesis reaction by the fact that it will only have one product when you're finished with that type of reaction. Okay? The next type is a decomposition, and as you would expect by the name, it's exactly the opposite. We're going to take one more complicated substance and we're going to break it down into two simpler substances. So it breaks apart. The way we recognize a decomposition reaction is there is only one reactant, only one thing to break apart. A single replacement, it can be either a metal replacing another nonmetal in a compound, or, excuse me, I said that backwards, a metal replacing a metal, or it can be a nonmetal replacing another nonmetal. So if I had this one, I'm going to have A plus BX, and A would replace B, so then I would get AX plus B. Or I could have a nonmetal replacing the metal. The nonmetal, excuse me, I did that twice. The nonmetal replacing the other nonmetal. So then I would get BY plus X. And the way that you can recognize if something is a single replacement is it's always going to be an element, so a single element by itself, plus a compound. On both sides of the equations, actually, be an element plus a compound. A double replacement is going to be two compounds, specifically two ionic compounds. So I would have AY plus BX yields AX plus BY. So they switch places. The positives and the negatives still have to go together. So you would recognize this by the fact that there is two compounds on both sides of the equations. Those are just some key ways to recognize when you see an equation what type you have. The last one is a combustion, which means I'm burning something, and it's going to involve a hydrocarbon, so I'm going to do this CH with numbers because those can vary. Anytime I burn something, I have to have oxygen, and the nice thing about those is they always make CO2 and water. And the way you'll recognize those is it will have a hydrocarbon, which is hydrogen and carbon together, and that is something we usually will go ahead and give you the formula for. Excuse me. Okay, so let's go on to talk about composition reactions first. All right, so a little more detail about composition or synthesis is where two or more substances, elements or compounds can combine to form one more complex. And again, we're always going to recognize that by the fact that we will have one product when we are finished. Okay, so let's work a couple of examples, or actually let's talk about the examples in your notes. Okay, these are listed there for you to know what these things can form. Okay, so when you're going through these problems of predicting what they're going to make, please refer back to this. Okay, there's no way for you to know this without having these guidelines. So please refer back to this when you're going through these. Okay, so first thing is a group. Metals can form with a nonmetal, and they form a salt, which is basically an ionic compound. So when we say salt right there, let's put in parentheses. Basically, it's an ionic compound, a metal plus a nonmetal. Abbreviate a compound like that. Excuse me, two nonmetals are going to form a molecular compound because remember they're sharing their electrons. Two compounds may form a single product, so this is two, oops, sorry about that, let me go back, my apologies. This is two compounds forming a more complicated. a metal oxide plus water can form, and this is a mistake, so please, this is important to cross this out. A metal oxide plus water will form a metal hydroxide. Okay, so make sure you make that correction, a metal hydroxide. Okay, I need to make that correction for next year. Okay, so a couple more, and that is metal oxide plus carbon dioxide will make a metal carbonate. A metal oxide plus sulfur dioxide will give us a metal sulfite, and then a non-metallic oxide plus water will give us an acid. Okay, so now on your left side activity for this synthesis reaction, you have some practice ones, and I just want you to practice predicting them and then balancing them. But I am going to do a couple examples for you. Okay, so I'm going to do example number 1. So of course the key here is knowing what to write. So we're going to do number 1. Calcium we write as Ca when it's by itself. It does not have a charge. So we just write calcium. Oxygen, we talked about this when we were balancing. Oxygen by itself is a Brinkelhoff, so it's O2. Okay, so we're going to say, what would this form? Well, the only thing it can form is calcium and oxygen combining together. So this is where we would go look at our charges on our pink sheet, or knowing where they are on the periodic table. And we know that calcium is a group 2 metal, so it's got a +2 charge. Oxygen, when it forms an ion, is a -2, and so it's going to form calcium oxide, CaO. Okay, so when we're predicting these, the first thing you need to do is get your formulas written correctly. Okay, do not try to balance it until you have your formulas written correctly. And the way you're going to write the formulas, if it's an ionic compound, you're going to balance the charges just like what we did in our nomenclature unit. If it's molecular, you put them together in a different way. So now I see that I need to balance this. So I see that I have a 2 right here for oxygen, and I only have a 1 right here. So the way that I can fix that is to put a 2 in front of there. And now I have 2 calcium, so I need to go back and put a 2 in front of there. And now I double check that I have 2 calcium and 2 oxygen on both sides, and I do, so that is balanced. Okay. So now let's do number 5, which is hydrogen and chlorine. Those are both Brinkelhoff elements when they're by themselves. So we're going to write H2 plus Cl2. Now we have that written correctly, so now we ignore those subscripts when we write them on the other side. Now we look at what the charges of those things would be, and we put them together based on that. So we know that hydrogen, when it's in a compound, is a +1, and chlorine, when it's in a compound, is a -1. So they go together in a 1-to-1 ratio, so it would be HCl. And now I need to balance. Okay, I have 2 hydrogen and 2 chlorine, so it's very easy to fix by putting a 2 right here. Okay, so now let's do number 11. I have aluminum plus oxygen. And now I would put those together. Again, I look at what their charges are when they're in a compound. Okay, so aluminum is +3, oxygen is a -2. So I'm going to do my crisscross and say that my formula would be Al2O3. So now I need to balance this. I notice that I have 2 oxygen here, 3 oxygen there. The only way to get that balance is to make them both be 6. So in order to do that, I'm going to put a 3 in front of this first oxygen, and I'm going to put a 2 in front of the second oxygen. When I do that, that gives me 4 total aluminum, so I'm going to put a 4 here, and now it is balanced. Okay. When you're going to put the rest of those together for synthesis, please pay attention to what they can make. Okay, make sure you're using the list of things that I gave you to predict. Okay, so now we're going to talk about the lab a little bit. Okay, these are some examples from the lab. Okay, there was actually quite a few synthesis examples from the lab. I will tell you that the ones that we did that were synthesis, so that you'll make sure you understand that, was when we burned magnesium. So burning magnesium. Okay, anytime you see burning, that means you're going to need to add oxygen. Okay, And when we add oxygen, it's Brinkelhoff, okay? So we would say Mg plus O2, and then you would put that together the way it goes, okay? Also, the question about, in addition to oxygen in the air, is some nitrogen, so then you would add that as Mg plus nitrogen, and then you would predict what that makes, okay? And then I will give you a hint that when we added the phenolphthalein and it turned that pink color, and it tells you that that's the presence of a base. So what we did is we had magnesium oxide. When we burned it, we added water to it, and then we made something. If you'll go look in your notes under metallic hydroxide, I just gave you the answer, sorry. Okay, well, it makes a metallic hydroxide. Whoops, didn't mean to do that. My mistake, your gain. And then there's a couple of other ones in there that I want you to find on your own that are synthesis, but they're always going to be recognized by the fact that they are one product when they're made. Okay, so now let's talk about decomposition. Decomposition is the exact opposite of composition in that we have one thing and we're going to break it down. And the way we recognize that is the fact that it would have one reactant. Only one reactant. Okay? The things that it makes and predicts that, I'm going to go through that very quickly because basically they're the exact opposite of composition. If you look at those, if you have an ionic compound, decomposes into a metal and a nonmetal. Okay? So you can read through those and look at those when you need to. So I'm going to go through that pretty quick because our video is already getting a little bit on the long side. So I'm going to let you go through and read those. So let's practice a couple of these. Potassium carbonate. Again, we got to know how to write that correctly. So potassium carbonate. Potassium is a +1. Carbonate's a -2. So we would write this as K2CO3. And we're going to break it down. And if you go look at metallic carbonates, it will tell you that a metallic carbonate breaks down into metallic oxide plus CO2. So I know at the very least I'm going to get CO2. Okay? And then potassium oxide is what I'm going to be left with. And so again, you got to know how to balance those charges. So you'd have K2O. And now we need to see if it needs to be balanced. And actually it doesn't because I already have one carbon, 2 potassium, 2 potassium. And then here I have 3 oxygen, and I have 2 + 1 is 3. Okay? Next one is iron 2 hydroxide. Remember that 2 is telling you that it is got a +2. So we would write this as FeOH2. And then we would break it down. If you go look at your list, it tells you a metallic hydroxide decomposes into a metallic oxide plus water. So I know I'm going to get water. And I'm going to do metallic oxide, which will be iron 2 oxide, so it's just going to be FeO. And if I look at that, I am already balanced. I have 1 iron, 2 hydrogen, 2 hydrogen, 2 also oxygen, 1, 2 oxygen, it's balanced. Okay. Potassium chlorate, KClO3. If I look at my list, it tells me a metal chlorate decomposes into a metal chloride and oxygen. So it's going to get just Cl, okay, plus oxygen is O2. So when I balance this, I see a 3 and a 2. So the only way to do that is make it be 6. So I'm going to put a 3 in front of there, a 2 in front of there, and then that will require me to have a 2 there. Always write your equations correctly before you try to balance it. And then the last one is Ag2O. Because silver is a +1, oxygen is a -2. So the only thing it can break down into is silver and back down into oxygen. And remember, when we write oxygen by itself, we have to have a diatomic. So I have to put a 2 in front of this formula so that I can get 2 oxygen. And then when I do that, that requires me to have a 4 in front of silver. Okay? All right, let's talk about examples from the lab. And there really were no examples of decomposition in the lab. Okay? So no examples from the lab. We didn't do any decomposition reactions. Okay? And that ends the video lesson for today. We'll talk about double and single replacement and combustion in the next lesson.